It's time to talk about heaps, like those piles of stuff in your room you meant to put away. Binary heaps are often used to implement priority queues. These data structures fill up from left to right and top to bottom. One of the reasons we don't usually implement most trees using arrays is because of all the empty space. But with heaps, it works. The most nodes there will be at a height h is n over 2 to the power of h plus 1. Since this is implemented on an array, you can label each node by its position in the array. This is a sequential index. If you want to get a node's parent, you take that node's location, and it's, in the numerator, the index minus 1 over 2, rounded down. For any heap, we can turn it into a max heap. This means that every child is of lower value than their parent, and by extension, all its descendants. This doesn't put them in order, but still has many useful properties. This happens in order of h time. It's also order of n log n, but that isn't a tight upper bound. We put these into a max heap configuration through something called max heapify. It truly has the most awesome name of all time. This starts with a triangle at the parents of the leaves and goes through switching any child that is larger than the parent and its sibling with the parent. This has a runtime of order of log n, or order of h. This is because max heapify will need to be called once for every level in the tree. A fun thing you can do with these max heaps is to use them as a sorting algorithm. I love sorting algorithms. Since we already know the number at the top is the largest, we can swap it with the last element. This element is now correct, and we can section it off by decreasing heap size by 1. After that, we have to fix the heap since we messed it up. Then we repeat the process until we have a sorted array. Amazingly enough, this comes out to have a runtime of n plus n log n. It looks like it should be way worse, but actually performs pretty well. If we want to extract the highest number from a max heap and leave the heap in good condition, we essentially do the beginning of the sorting where we flip the first value with the last and then make necessary corrections. When we increase the key, we essentially change the I value to the new key and then correct the max heap.